All right, let's look at this example. We want to simplify these radical expressions. So we have square root of 20 plus 3 square root of 5. All right, so looking at these, they're not like terms the way they're written. All right? But what you need to watch out is to see if you can simplify the radicals to their simplest form. Okay, so that's really important. So what we learned in the last couple of sections where you're simplifying radicals needs to happen here. Right? So this one can be simplified because square root of 20 is square root of 4 times square root of 5. Right? Which gives me 2 square root of 5. And then we have the plus 3 square root of 5. That doesn't simplify anymore. Right? So we wrote simplified square root of 20 to its simplest radical form. And now we say that, oh yes, these are like terms. 2 and 3 gives me 5 square root of 5. Looks funny shape. And let's look at B. Cube root of 24 minus cube root of 375. All right, they're not like terms the way they're written. But let's see if we can simplify them. So think of cube roots, perfect cubes. 24 is 8 times 3. Right? 8 is a perfect cube, so cube root of 8 is 2, comes out. And then we have cube root of 3. Okay? Let's look at this one. 375. That's pretty big. So I know that 125 is a perfect cube. So let's say 375 divided by 125 is 3. Okay, so this one is cube root of 125 times 3. Cube root of 125 is 5. And the cube root of 3, that stays inside the radical. Alright, so now I can say, oh, these are like terms after I simplify them. So I have 2 cube root of 3 minus 5 cube root of 3. This is going to give me negative 3 cube root of 3. 3 is everywhere. Alright, let's look at C. 1/2 4th root of 48 minus 2/3 4th root of 243. Alright, now 4th root, it's harder for me to remember perfect cubes, fourths. Alright, so we're going to do factor 3. So this is 2 times 24, 2 times 12, 2 times 6, and 2 times 3. Alright, so these are my prime factors. Alright, so this is 1/2 4th root of, there's 4 2's here, 2 to the 4 times 3. And so this is a perfect 4th power. Alright, now let's do this one, 243. This divides by 3 and I get 81. 3 times 27, 3 times 9, 3 times 3. Okay, so this is 3 to the 5. So we get 2 to the 3, 4th root of, and I'm going to write it as 3 to the 4 times 3 because we want perfect 4th roots. Alright, so let's simplify. We have 1/2 4th root of 2 to the 4 is 2, and we have 4th root of 3. Then 2/3 4th root of 3 to the 4 is 3, and then we have 4th root of 3. Let's make these into fractions. 1/2 times 2 is 1, so 4th root of 3. 2/3 times 3 is 2, 4th root of 3. So 1 4th root of 3 minus 2 4th root of 3 is negative 1 4th root of 3. Yeah, so we simplify, and then we collect like terms if we end up with the same radical.